Next, we're looking at different properties of logarithms. And here we have the same base. So if we're adding these, we could condense this by talking about log base A, and what we would do with these values is multiply them together, so it'd be m times n, because we were adding and they had the same base. Here we also have the same base, base A, and because we are subtracting, then we're going to, as far as condensing this goes, take m divided by n. Now remember, logarithms and exponential functions are inverses of each other. So that would make sense then, based on our exponent properties, why we would multiply these together when it's expanded with addition, and why we would divide these when it's expanded with subtraction. And here we have a power to a power, so we're going to multiply. We're going to take n times the log of log base A of m. So we can move that exponential value out to the front, and we multiply the logarithm by that. Using these properties, we can take these logarithms and rewrite them, and here we're asked to write them in terms of either log of 3 or log of 5. So for example, this 75, we could think of that as, we have 25 times 3. So there's a 3. Let's say that 25 is like 5 squared. So if we expand that out, we would have log 3 plus, because remember we're saying here that we can add those together, plus log of 25, which is 5 squared, so that's 2 times the log of 5. This gives us our 25. 25 times 3 is 75. Here we have log of 27 divided by 25. Again, the log of 25 we could think of as 2 log 5. As far as that 27, that'd be like 3 cubed. To give us our division, we are going to subtract them. So if I have 3 times the log of 3, that gives us our 3 cubed. That's the 27 minus, there's our division, and then we have 2 log 5. Remember, that would be 5 squared, so that's our 25. Next two examples, we're going to use those same properties to either expand this logarithm or condense this one. Again, still using those same properties, now expanding or condensing. So for example, the division here, we could separate this. We're talking about log base 3 of 4x squared minus log base 3 of the square root of y. Let's see, square root of y, that's the same as y to the 1/2. We could move that 1/2 out in front. Let's see, we could separate these two. So we have log base 3 of 4 plus log base 3 of x squared. Let's see, I could move that x squared, that 2 out in front there as well. And so then we'd have the 1/2 for the square root, log base 3 of y. So now we have expanded that logarithm using those properties. To condense these, the first thing I notice is the subtraction here, so we could divide those two. We do have the same base. If nothing's written, we think of it as base 10, and that's an x plus 3 divided by x minus 2. The 2 out in front means that quantity is squared. And then we still have the 2 there, so we could then square that entire thing. Log of x plus 3 over x minus 2, and we're squaring all of this, so that would end up being this quantity squared, and then when I have this one squared, we already had it squared before, so that would go to the 4th. So then that one is now condensed from its longer version, again using those same properties. Two more examples. Here we can, again, same base, just look at the exponents here. So then we were saying that the exponent here, 2x, would be equal to our exponent on this side, x squared minus 8. Again, anytime we have a quadratic, we want to set it equal to 0. I'm going to subtract that 2x over to this side. So now we have x squared minus 2x minus 8. Factor that. So we were going to have a x minus 4 times x plus 2. So then that gives us two values. X minus 4 equals 0, so that's where x is equal to 4, and where x plus 2 equals 0 is when x is negative 2. So those would be our two answers there. Over here, our exponent is a variable. We're going to need a logarithm to be able to solve this. First, I'm going to divide the 2 over. So I'll have 5 to the x. We want to get our base with the exponent by itself first. Now 5 to the x equals 16 as far as a logarithm goes. Our base is 5, so log base 5 of 16 is equal to x. I'm going to need to use change of base to be able to solve that. And then with our calculator, so we have the log of 16 divided by the log of 5. We find that x is approximately 1.72.